For today's lesson, we're going to be combining two of the things that we've learned about previously in geometry. You will need your in-class 31 to follow along, and we are going to be writing two kinds of proofs today that actually go back to standard 5 and congruent triangles, but combine that information with our parallel line information from standard 6 and now standard 7. So, at the top of our notes sheet for today, before we get into the proof examples, we have some important reminders about congruent triangle proofs, since it's been a few days since we took that summative assessment. So remember, when we're proving that triangles are congruent, we're going to use one of these 5 reasons: side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. And then after triangles are congruent, for one of those 5 reasons, we can use CPCTC to show that other corresponding sides or angles are also congruent. That was pretty typical when we were dealing with our standard 5 proofs. Every proof involved congruent triangles, but then some of the proofs involve CPCTC, or they involve CPCTC plus the use of some kind of definition to prove that a vocabulary word exists. So what we need to do probably is also to be on the lookout for 2 things that helped us out when we were in congruent triangle mode. That was the reflexive property to give us an extra pair of congruent sides, and then also vertical angles theorem to give us an extra pair of congruent angles. So we're going to watch for those and see how they can help us or also be involved where parallel lines exist or need to exist as well. All right, all that's left is for us to jump in and see what happens with these particular proofs. As you can tell in the pictures, we do see some triangles, so that's a pretty good indicator that we might be using congruent triangles to help us along. We also can see that we are given parallel lines in both of these situations. And so when we were doing congruent triangle proofs before, we didn't have that. We would be given midpoints, or we would be given angle bisectors or isosceles triangles, or just congruent sides and angles, and then we would find our congruent triangles from there. But now we're going to have parallel lines or parallel segments that we can use to help us out along the way. Keep in mind that if segments or lines are parallel, they always lead us to congruent angles. So these are going to be clues about additional sets of congruent angles that we can find in our triangles. All right, let's jump into this first one. We are being told that segment AB is parallel to segment CD. So I'm going to go ahead and highlight those a matching color. And then I'm going to put those parallel line arrows on the picture. And then I can see that there are 3 different transversals connecting those parallel lines. But if I were looking at this bottom transversal or this top transversal, the angles that are formed would be consecutive interiors. That means they would be supplementary, plus this angle, all of angle B, doesn't exist in a single triangle. It kind of spans across an angle from the bottom triangle and an angle from the top. The same thing happens down here. Angle D doesn't exist only in the top triangle or the bottom triangle, but it's both of them put together. So the most helpful transversal for us to focus on when we're trying to figure out how these parallel lines are going to be helpful is this segment BD that travels through the middle. Because now, if I look at where pink and yellow come together in this triangle, and I look at where pink and yellow come together in this triangle, I do get a set of angles, one angle for the bottom triangle, one angle for the top triangle, that will be congruent. They are on alternate sides of that transversal, and they are interior, trapped between the parallel lines. And so I can use this segment AB parallel to segment CD given to formulate angle ABD congruent to angle CDB I have to use 3 letters to name those since there's a lot happening in the corner where B and D are at. And those are alternate interior angles. So my alternate interior angles theorem, not the converse, but the theorem, tells me that those 2 angles are congruent given those parallel segments. I can mark that with an A to show that I've accomplished a pair of congruent angles. And then because my goal is to get to congruent triangles, I know I need to keep going, finding more congruent angles and congruent sides as I go. The good news is I have another given. Angle A is congruent to angle C. That's not true because of the parallels, but it is true because it was given to us to use. So we're now up to 2 pairs of congruent angles. And if we're thinking back to our 5 reasons that we wrote down at the top, we don't want a 3rd pair of angles because angle, angle, angle is not a valid reason for congruent triangles. So we need to be looking for a pair of congruent sides to go along with all these angles we've already listed. Remember, we're supposed to be keeping an eye open for reflexive property and vertical angles theorem. So this is going to be an opportunity for me to use reflexive property. I am going to be a little bit careful because if I'm traveling from B to D in this triangle, that would match the reverse direction in the other triangle. So when I write my reflexive property statement, I'm going to go ahead and flip-flop those letters to show that correspondence correctly. That gives me a pair of sides, and if I have 3 things marked out, I should be ready for my prove statement to show that triangle ABD is congruent to triangle CDB. I just need to make sure, since I have 2 A's and 1 S, that I make a really careful decision between angle side angle and angle angle side. If I look at that side that's highlighted yellow, it is only connected to one of my 2 congruent angles that are marked. So this should be an angle angle side situation. All right, let's go ahead and take a look at number 2 and see how it is different. It looks like this time my parallel segments are BC, so up top, and AD down at the bottom. I still think, though, that transversal through the middle is going to be the best choice because it's going to provide another opportunity for me to mark alternate interior angles as congruent. So if I write my given, segment BC is congruent to segment DA. And then remember that anytime those parallel lines pop up, I'm going to use them to talk about congruent angles. I just need to carefully name my angles with 3 letters. So that top one would be angle CBD. That bottom one would be angle ADB. Again, those angles are alternate. They're on alternate sides of that transversal, and they are interior for my parallel lines. Forgot to add the flag, so I just did that. So we're going to use that alternate interior angles theorem again, and that gives me a set of congruent angles. Moving to my second given this time, it's a set of segments or sides instead of angles. I don't need to worry about why AD is congruent to CB. I just need to mark it. Being parallel is different than being congruent, so we do want to make sure that we mark it as both since we know both facts. That would be a pair of sides. And then my last piece of information I think is still going to be that reflexive property where segment BD, if I travel from B to D, would need to reverse itself to match and correspond what's happening in the other triangle. And so once I get that finished out, it looks to me like this one is hopefully a side angle side situation since we have 2 S's and 1 A. If I follow where those sides that are congruent intersect, sure enough, the angle is right where it belongs. So I'm going to copy that proof statement. Triangle ABD is congruent to triangle CDB by side angle side. All right, go ahead and flip the page and meet me back here for a few more example proofs. We have 4 more proofs here on the back side, so let's see if these start to look a little bit different. I'm seeing some pretty similar things here in number 3. I've been given some parallel segments. I do see a vocabulary word popping up, so I'm going to need to work on that. I see triangles in the picture, so I'm still probably going to prove that triangles are congruent, but I'm also noticing that they want me to end with segments. So this is probably going to be one of those situations where we're going to have congruent triangles for sure, but then we're going to follow that up with CPCTC. So just keep in mind that congruent triangles are a very helpful tool, even if your proof statement does not specifically say you're supposed to be proving that triangles are congruent. But let's go ahead and jump in and see what we come up with. Segment AD is parallel to segment EC. Just something important to know. Parallel does not mean congruent. Some people will read that given and they'll be like, well, don't we already know what we're trying to prove? And the answer is no. Things can be parallel, like I can draw a parallel here to something here, but they could be very different lengths, short and long. And so what we're doing is we're saying they're parallel first, which remember is going to be used to talk about some angles afterwards. And eventually then we're going to want to spiral back around and get to the point where these sides match in length. They're congruent, so they can get a tick mark instead of a parallel flag. But we're not there yet. Okay, I have 2 transversal choices. So I could travel from A to E to connect those parallels, or from D to C, or both in this case. I'm going to choose this way, but there's nothing wrong with choosing the other way. And I notice when I do that, I end up with angle D and angle C as alternate interiors. We've seen alternate interiors in all of our problems today. That's just because they are the most common when we're dealing with pictures that also include triangles. So that gives me a pair of angles. And now I have a choice. I could switch to the other transversal and get a second pair of congruent angles. Perfectly fine. Alternate interior angles theorem would be another reason to go along with that. Most of us, though, are used to using our given for only one piece of information. So most instincts say to move on to B is the midpoint of segment DC. So I'm going to go ahead and do that just because that's what most of you would try to do if I forced you to try this on your own. If B is the midpoint of segment DC, I'm going to be able to mark that these 2 parts of the segment, so segment DB and segment CB, are congruent using the definition of midpoint to give me a congruent pair of sides. And then at that stage, most of us would say, well, with 1 pair of angles and 1 pair of sides, I better be looking for some reflexive property or vertical angles theorem. And you would notice vertical angles theorem here in the middle. So we would say angle ABD maybe for that vertical angle on the left is congruent to angle EBC, that vertical angle on the right. But it would have been perfectly acceptable, instead of including vertical angles, to instead have that second pair of angles from alternate interior angles theorem that we talked about at the top. The only difference that would happen if that were the case is that this situation might be angle side angle, is angle side angle, and if you had done that set of angles instead, you would be looking at angle angle side. So you'd have some differences, but it would be 100% correct, perfectly acceptable way to do the proof. All right, now that we're up to 2 pairs of angles and 1 pair of sides, we're ready for our congruent triangles. I'm going to name them based on the way that I named my vertical angles, because I was really careful when I named my vertical angles to match up corresponding parts. And so that means that using angle side angle, this side is in between both angles that are marked. Same thing over here. These triangles are congruent. Now that was not my ultimate goal, but I knew that ahead of time. And so CPCTC is going to help me finish this one out. does AD, the segment they're asking me to prove something about, correspond to EC? Looks exactly the same in both of those names. So I'm able to say that those segments are congruent because corresponding parts of congruent triangles are congruent. All right, 3 proofs down and 3 to go. Number 4 is the first time today that we have not been given parallel lines or segments. Instead, we're being asked to prove that there are parallel segments. Hopefully you remember from our previous lesson that that means there's going to be a converse involved. So I'm going to tell myself that. I also see triangles in the picture. So maybe triangles followed by some CPCTC are going to help me get to that converse. Let's go ahead and see what we know and start marking it up. Segment BD is congruent to segment BC. So that would be one pair of sides already congruent because of that given. Second given, B, is the midpoint of segment AE. And I know that midpoints are going to be useful for more segments. So B is the midpoint of AE. I would get to mark segment AB congruent to segment EB using my definition of midpoint. So I'm pretty confident at this stage, since I already have 2 pairs of sides lined up, that I am definitely headed towards congruent triangles. I'm out of givens, so that means I'm on the hunt for reflexive property or vertical angles. It's going to be another set of vertical angles here. So angle ABD is congruent to angle EBC. Be careful to match up those corresponding parts if you can, because if you do that in your vertical angles theorem statement, then afterwards, since we've got 2 pairs of sides and 1 pair of angles, side angle side, I can just take those angle symbols and turn them into triangles, and I've got my triangle congruent statement already ready to go. Okay, now let's think. Our goal was to get to a converse. So if we think back to our previous proofs, all of the converses said if some kind of angle is congruent or supplementary, then lines are parallel. So I'm going to use CPCTC to talk about some angles being congruent so that after that, I'm going to be able to talk about these segments. Oops, I made a mistake there. And how they are not congruent to each other. That was my mistake. But parallel to each other. So AD parallel to EC. So let's look. If I want AD to be parallel to EC, I'm going to need to find some angles that are along a transversal. I'm going to go ahead and stick with the same transversal I used here, except I didn't know at the beginning of this problem that these were parallel. But now that I know these triangles are congruent, I can mark and I can say, using CPCTC, that angle D is congruent to angle C because they're corresponding parts in my congruent triangles, so they have to be congruent. Now, the really great news about that is that those 2 angles are alternate interior. And so my parallel segments happen because alternate interior angles converse tells me that anytime I can see alternate interior angles that are congruent, I will be able to say that the segments or lines attached to them are parallel. So kind of a combination of our congruent triangles and then using CPCTC and not a definition afterwards, like we have before, but a converse afterwards to prove that those segments are parallel. All right, 2 left. And it looks like both of them start us out with some parallels. One of them has us ending on some congruent segments, and the other one has us ending on some parallel segments. So those parallels at the end are definitely going to put me in converse mode. And I think for both of these, we're going to be in CPCTC mode, because that CPCTC is going to help us get to the congruent segments or get to the angles that we need for the converse. Okay, let's deal with one pair of parallels at a time, especially over here where we've got two. So first things first, segment EF is parallel to segment GH. So if we get that written down, and I highlighted them the same color, our goal would be to track down a transversal so that we can turn those parallels into some congruent angles. I think the best transversal to use is going to be this one through the middle, like it was on our previous problems, so that we can say that angle and that angle attached to the parallels, but also on alternate sides of that transversal, would be congruent. Those are alternate interior angles. So our regular theorem, not the converse, we have the parallels, we're talking about the angles. So the regular theorem tells us that angle EFH, the one on the bottom, is congruent to GHF, that one in the top. That's one pair of angles tracked down. Next up, we're going to have segment FG parallel to segment HE as a given. That is another pair of parallels, so I'm going to try to use that to get another pair of angles that are congruent. Let's see if I can get a different color here to highlight those. FG is parallel to HE. So now I'm looking at the green parallels with that yellow transversal, and I'm noticing these angles tucked into those corners. So that would be angle GFH and angle EHF, which are also alternate sides of that transversal and interior angles for those new green parallel lines or segments. So we're up to two pairs of congruent angles. If I'm heading toward congruent triangles, I'm going to need some sides here in step number 5. So I see that shared side is back that we can mark as being congruent. Ooh, that's an F right there, not an E. Congruent to itself. So segment FH is going to be congruent to HF. Another situation where we've got a rotation happening. So those reflexive property letters get flip-flopped. And then if I'm to the point where I have 2 A's and 1 S, that means I am ready for my triangles. I was careful in both of these cases to match up corresponding parts, so I can pick either of them to turn into my triangle names. But I do need to make a really careful decision between angle, angle, side, and angle, side, angle. My side is right here in the middle. This picture's a little crazy, but it's connected to both of the congruent angles in both of the triangles. So this would be an angle, side, angle situation. All right, if there's more to do, then CPCTC is my friend after the triangles are congruent. So if I check out segment EF, that's right here. Does that correspond to segment GH? It sure does. And so since the goal is to say that those two segments are congruent, I can do exactly that with CPCTC and finish that proof number 5 from our notes. All right, one more. Proof number 6. Starting out with only one set of parallel segments this time. Segment FG is parallel to segment HE. Go ahead and add some color onto those. Put my parallel line flags on there. I think it's probably wise to use the same transversal we've been focusing in on through the middle there so that we can find some angles in each triangle to talk about as a result of those parallel lines. They are still alternate interior angles, so that theorem will explain why angle GFH from the top triangle is congruent to HEHF from the bottom. That gives me a pair of angles. Moving on to my next given, it looks like I'm going to have more angles out at angle G and angle E. Angle G and E. Still have a reflexive property option for a side. Side FH is going to be congruent to HF. And since I have two pairs of angles and one pair of sides, that means I'm ready for triangles. Again, I was careful with my angle name earlier, so I'm going to turn that into a triangle name so that all those corresponding parts are matched up. One more time, let's think about angle side angle versus angle angle side. That reflexive property side seems like it's only connected to my angles with the double arc, not the single arc. So that would be angle angle side this time. And then since I have more to do, I know CPCTC is going to be involved, but that is only going to tell me that things are congruent, not parallel. So I need to think ahead to what would help me to know that EF is parallel to GH. If I stick with that same transversal, I think the key is those two angles in the corner. If angle EFH were congruent to angle GHF, those look like alternate interior angles to me, which would then force these sides to be parallel using a converse. The question is, do those correspond? So from E to F to H, first, third, second letter, GHF, first, third, second letter, so it works. That means we're going to be able to make our conclusion that segment EF is parallel to segment GH, not using the alternate interior angles theorem like we did at the top, but converse, because we're starting with the angles and we're ending with those parallel segments. All right, all of our examples today did use alternate interior angles theorem, but I do want you to be aware that that's not always the case. So when you're working through your assignment, you could have opportunities where you see corresponding angles postulate or corresponding angles converse or alternate exterior angles theorem or alternate exterior angles converse. They're just not quite as common as alternate interior angles theorem. All right, that's it for In Class 31. We will see you back in class.